Algebra 1, welcome back. Today we're going to be taking a look at section 5, and this one is titled Use Square Roots to Solve Quadratic Equations. And wanted to let you guys know that I found another good video from Edpuzzle that I'm going to be posting with this. I think it's just kind of an enhanced way to make sure that you guys are getting exposed to the material as much as possible, since you're not here physically in the classroom. So you get to see me do it up on the board. You'll have homework on it. You'll have another Edpuzzle video that will guide you through the steps, just continually exposing you to the material and asking you questions through that as well. All right, so let's take a look at what we have going on here. So with these problems, again, pause it if you need to, that we can copy all these notes down. But with these problems, you're trying to isolate the term that's going to have either the x squared or basically just the squared exponent in it. So it doesn't matter what variable they use in your homework problems. So I'm going to be using x throughout all of my example problems, but they can use any letter. That doesn't matter. It's just that you're trying to isolate the term with the square in it, okay? And you essentially are going to be doing the opposite function to cancel out all the other terms, okay? So by other terms, like in this problem it'd be, how do we get rid of that 4? Or in this problem over here, how do we get rid of that 4? Noticing that it's next to a set of parentheses, that's different than this one over here. Or in this first problem that we do, we're going to ask first, how do we get rid of that 100? And then, how do we get rid of that 4? So you're trying to get closer and closer to isolating that variable that has the squared with it. Okay? So again, think of it as you're going to do the opposite function to first try and cross something out. That opposite function might be adding, subtracting, multiplying, or dividing to get closer and closer to that variable with the exponent. And then once you get to that exponent, how do you cancel it out? Because your answer cannot say x squared equals. That's not done yet. So you got to get rid of that squared. And how do you do that? It's this right here. You're going to use the square root. That is what will cross out a square. So here's a very simplified example. If you're down to x squared, how do you cross that out? You take the square root of x squared, and it's going to equal x. And something that I'm actually going to add to this is it's actually going to equal a plus or minus version of that x. Okay? So you remember that when you take the square root of something, like what's the square root of 100? It could be plus or minus 10, because the question would be, what's 10 times 10? Well, that's 100. But what's negative 10 times negative 10? That's still 100. So you don't know which one it's trying to represent, so in your answer, you have to show both. And that symbol right there, plus sign over a minus sign, is how you represent both answers, positive, negative. Okay? Another little example that's a little bit more detailed, or it might look a little more confusing to you, is if you have an entire expression, x plus 2, in a set of parentheses, and then that whole expression is squared. Well, how do you get rid of that? Same exact steps, okay? You're going to take the square root of the entire expression, and then it's going to cross out that squared. So really it's kind of like they're doing that to each other, crossing each other out, and then you're just left with the expression x plus 2. Okay, so you're going to see that being used in some of these examples here. One thing, I put this big arrow by it because it's super important. You can't take the square root of a negative. So if you get in a problem, and you have done it correct all the way to the end, and then you notice you have to take the square root of a negative, that's not possible. So ultimately, your answer is going to be no solution. And you're going to see one of our examples here does that. Okay? And then the last part, it's just a reminder. Your answer should have plus or minus in front of that number. just like we did over here. And you're going to see me work those out. All right, so let's take a look at the first example. So how are we isolating x squared? The first thing we can do is get rid of that 100 by saying plus 100. All right, and that's going to get us down to 4x squared equals 100. Okay, now we got to get rid of that 4, and the opposite function of that would be division. So we divide both sides by 4. 4's cross out, 100 over 4 is 25. Now we're getting down to that point where we are nearly isolating the x, but we still got to get rid of that square. That 2 is going to get rid of itself by taking the square root. Remember, that's this note right here. No, sorry, not that note right there. This note right above it. Square root will cross out a square. So here and here. And remember, what you do to one side, you do to the other. So x equals, and here's that plus or minus 5. Because we don't know which value it's going to be, positive or negative. So there's our solution right there. Okay, let's take a look at the next one. Looking at it, we can immediately go in and use division to get rid of that 25. Okay, 25, 25. All right, that crosses out, and you have x squared equals, and you'll notice 16 over 25 does not seem like a nice fraction. However, if you look really closely at it, there's something special about the 16 and there's something special about the 25 that if I just bring it directly down into this next step, each of these numbers, 16 and 25, they themselves are perfect roots, meaning I could take the exact square root of those numbers and it works out very nicely. So again, how do we get rid of that square? By taking the square root. And we could take the square root of both of those numbers. So if you want to think of it as what's the square root of 16 divided by what's the square root of 25, that's another way to think of it. And you'd get x equals, don't forget, plus or minus 4, square root of 16 is 4, over 5, because the square root of 25 is 5. So there's our answer right there. And you would leave it just like that in the fraction. Do not convert those to decimals. Please don't. All right, next one. Here we go. Got a 0. I can get rid of that 64 by subtracting it from itself and subtracting it from 0. So that goes away. I have 49x squared equals a negative 64. Now, if you're looking closely at this problem and you're looking closely at the notes up here, maybe you're able to see kind of into the future, if you will, something special about this. Look at the main arrow. Can't take square root of a negative. This is going to work out to be that problem. Divide 49. Keep showing your steps. X squared equals a negative 64 over 49. Now, yes, 64 is a perfect root. 49 is a perfect root. So if you said, oh, well, all I got to do is take the square root, I'm still going to get my answer, you got to notice that 64 is a negative. And because it's a negative, right here, can't take the square root of that negative. That negative sign essentially affects the whole fraction. So even though those would cross each other out, it won't work on this side. So this is going to be a problem where you actually are saying no solution because you can't take the square root of a negative. So that's a good example to take a look at for problems like that. All right, move on to the next one here. No longer do we have a 0 over there, so we're going to still need to isolate it, subtract 4, that's our first step, cross those out. X squared equals 31 minus 4, let's see what we get here, 27. Okay, now 27 does not work out nicely in terms of a square root, but you guys need to remember we've learned how to reduce radicals or reduce square roots. So let's review that. Cross those out. so the x is now by itself. 27, even though it doesn't work out nicely, we can use that little factor tree method that we learned in the past, and you're going to get square root 9 and square root 3. 9 times 3 is 27. Now, 9, I'm going to erase that x, give a little bit more space here. So let's put that down there. What is the square root of 9? That works out nicely. That is just the number 3. And the square root of 3, we're going to leave it because it's a prime number, can't work out nicely. So our final answer is simply 3 radical 3. All right, there's our value for that one. Now, let's take a look at this final example. So, you'll notice we have an expression all squared, so it's going to be similar to this example that's directly above it. All right, so pay close attention to that. Now, how do we isolate it? Well, we got to get rid of that 4 first, so divide both sides by 4. All right, so we're going to cross out that 4, cross out that 4. The x minus 3 squared is now able to drop down. And then 28 divided by 4, unfortunately, that's not going to necessarily work out nicely, but I can reduce each of those, right? I can reduce each of those by 2. So let's see, we're going to take 28 divided by 2, 14. Actually, that is working out nicely, my bad. A little bit tired here. That's going to be 7, right?